Well, welcome to another video in which we're going to explore limiting reactants. But in this video, we're going to look at how to find them using an advanced shortcut approach. So I would only advise doing this approach if you are comfortable using the longhand approach from the other video. So to use this approach, we're going to set it up right underneath our equation. And we're going to label our have and our use. So what we're going to do, which is different in this approach, is we're only going to stay on this side of the reaction. We're only going to be working with our reactants. We're going to completely ignore our products and just compare our moles of reactants to each other. So the very first step that we have to do is I have to determine how many moles of each reactant I have. So I have 18.1 grams of NH3 and 90.4 grams of CuO. Well, I know that my molar mass for NH3 is 17 grams per mole, and that my molar mass for CuO is 80 grams per mole. So to get the number of moles that I have, I need to divide what I've been given by the molar mass. So I'm going to divide 18.1 divided by 17, and I'm going to get 1.06 moles. And I'm going to do the same thing for CuO, 90.4 divided by 80, and I get 1.13 moles. So in this question, what I really have is 1.06 moles of NH3 reacting with 1.13 moles of CuO. Determining how much of each of these reactants we're going to use is sort of the tricky part, because what I want to figure out is which one I'm going to use up completely and which one is going to be left in excess by comparing the reactants to each other. So I essentially need to use my mole ratio step to go from my moles of one reactant to my moles of the other reactant. So if I have 1.06 moles of NH3, I want to know how much CuO I need to react with all of my 1.06 moles of NH3. So I'm going to use my mole ratio step to determine that if I have 1.06 moles of NH3, I actually need 1.59 moles of CuO to completely use up my NH3. So when I look back to what I have, I don't have 1.5 moles of CuO. I only have 1.13 moles of CuO. So I'm not going to be able to use up all of my NH3. So most likely my NH3 is going to be the one that's going to be in excess. But just to check, let's determine how many moles of NH3 are needed to react completely with my CuO. So when I do my stoichiometry with my mole ratio step, I find that it will take 0.753 moles of NH3 to use all 1.13 moles of CuO. And I do indeed have enough NH3 because I have 1.06 moles of NH3 and all I need is 0.753 moles of NH3. So I have enough NH3 to use up all of my CuO. So now I've determined that CuO is our limiting reactant and NH3 is going to be our excess reactant. So if CuO is my limiting reactant, I know that I'm going to use all 1.13 moles, which will require 0.753 moles of my NH3. So I'm going to use 0.753 moles of my NH3 to use up all of my 1.13 moles of my CuO. So now, even though we've determined to confirm what my excess is and which one's my limiting reactant, 1.13 times or minus 1.13 is 0. So at the end, I'm going to have 0 moles of my CuO and 1.06 minus 0.753, and I'm going to have 0.307 moles of my NH3 left over. So I'm going to have 0.307 moles of my NH3 in excess and none of my CuO left over. But they don't want to know how many moles of excess reactant I have. They want to know how many grams. So I have to take it one more step using my mole conversions. So if I have 0.307 moles of my NH3, now all I have to do is convert that into grams. So once I do my stoichiometry, I find that 0.307 moles is actually 5.2 grams of NH3. So I'll have 5.2 grams of NH3 left over at the end of this reaction. Okay, let's take a look at one more example, and I'm going to do a lot less math so I can demonstrate how to sort of do this math and these conversions in your head, which is why this is the more advanced approach, is because of the familiarity that you have to have with your mole heart and your stoichiometry pathways in order to do this quickly and efficiently. So when 10 grams of sodium is reacted with 10 grams of oxygen gas, what is the mass of the product produced? So my molar mass for my sodium, I know, is 23 grams per mole, and my O2 is going to be 32 grams per mole. Because in order to figure out what I have, I want to know what I have in terms of moles. So I take what I've been given, my 10 grams of each, and divide it by the molar mass for each of my reactants. So 10 divided by 23, and I get 0.435 moles. And for oxygen, I get 0.313 moles when I divide 10 by 32. So now to figure out what I use, I'm going to look at my Na, and if I have 0.35 moles, I need to multiply that by 1 divided by 4, because my mole ratio is 1/4, and to set up for my conversion factor. So to do this in your head, you're going to look at this number, 0.435, and multiply it by this over this coefficient divided by this coefficient. So always look at the opposite coefficient first, that goes on the top, and the coefficient for the reactant you're working with goes on the bottom. So when I do this, I get 0.109. So what this says is that in order to use up all of my sodium, I have to have 0.109 moles of oxygen gas, which I do have, so I should be able to use up all of my sodium. But let's check with our oxygen to make sure we're correct. So for my oxygen, if I have 0.313 moles of oxygen, I want to know how many moles of Na is required to completely react with that. So I'm going to have 0.313, and remember, go to your coefficient of the opposite reactant first. So this is 0.313 times 4/1, and I'll get 1.25. So to completely use up all of my oxygen, it will take 1.25 moles of sodium, which I don't have. I only have 0.435 moles of sodium. So I'm not going to be able to use up all of my oxygen. So I just put our original conversion back here. So I know that I'm not going to be able to use up all of my oxygen, but I am going to use up all of my sodium, 0.435, because I have enough of my oxygen to be able to do that. And to be able to do that, I'm going to use 0.109 moles of oxygen to use up my 0.435 moles of sodium. So now to determine my excess, I'm going to have no excess moles of sodium and 0.204 moles of oxygen left over. So my sodium is going to be my limiting reactant, and my oxygen is going to be my excess reactant. But what the question actually asked for is what is the mass of the product produced. And remember, the mass of the product produced, I can only produce as much as my limiting reactant will allow. So I need to determine how many grams of Na2O I'm going to produce from my 0.435 moles of Na, because that's my limiting reactant. So when I do my stoichiometry and I start with my 0.435 moles of Na, do my mole conversion step, and then finally my molar mass for my product, I get 13.5 grams of Na2O. So if I start with 10 grams of sodium and 10 grams of oxygen gas, my sodium is going to be my limiting reactant, so that is going to produce 13.5 grams of Na2O. And again, remember, this is the advanced shortcut approach. So if you're really comfortable with the other more basic approach, try this one out. Take a look at these examples. Try some previous examples using this approach and see if you get the same answer. But this will certainly save you some time if you are really comfortable with doing your mole conversions and stoichiometry.